Hey everybody, in this video we're going to start chapter 2, which is called Graphical Descriptions of Data, and specifically we're going to go over section 2.1, which is all about frequency distributions. In this section we're going to learn how to construct a frequency distribution, how to read frequency distributions, and we'll learn about why frequency distributions are important. So let's get started. Alright, so what is a frequency distribution? Well, the definition of the word frequency, that's going to be like a count. Alright, so frequency, if you calculate the frequency of something, that's like you're counting up how many times did it occur. A distribution is just a fancy word for like a table or a graph, and so this is a table of counts. Here's the formal definition. It says a frequency distribution is a summary that shows how often each value or range of values occurs in a data set. All right, so why are we saying value or range of values? Well, that's because depending on what your data set looks like, you might construct a frequency distribution slightly differently. So frequency distributions are always going to look like tables. All right, so typically you'll see maybe the variable name listed here. Let's say that this is just the age. And then here this is the frequency. And sometimes you'll just see this column called F for frequency. All right, so suppose I went out and asked, did a survey, or I'm doing some kind of experiment, and I collect some data on the people's ages. So maybe I've got 5-year-old, 6, another 5-year-old, a 4-year-old, a 3-year-old, another 6-year-old, and then let's do 2 2-year-olds and a 1-year-old. All right, so when you're looking at constructing your frequency distribution, if you're just doing each value, then you would just list out, okay, we've got people that are age 1, age 2, age 3, age 4, and age 5. Okay. Then for the frequency, you would just go in here and count up how many times did the age 1 occur. That was just once. So the frequency is 1. How many times did the age 2 occur? 1, 2 times. All right, so the age 2 occurred twice. The age of 3 occurred only once. The age of 4 occurred once. The age 5 occurred twice. And then I left 6 off, so let's add them on. There were 2 6-year-olds. All right, so this is one way to construct a frequency distribution. All right, so you just list each value, then you count up how often did that value occur. Now this part here, range of values, this might be for a really big data set. Maybe you've got people that are, 1, 2, 3, 4, 5, 6, but you've also got people that are like in their 50s and their 60s. Right, so if you had a really big data set with lots of what we call variation, which is just differences in the ages or whatever your variable was, then you might instead construct your frequency distribution and say like ages 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, and so on. All right, and then you could go in and count up, okay, how many people in my study were between the ages of 1 and 10? That would be the frequency. How many people are in between the ages of 11 and 20? That would be the frequency for that group. All right, so a range of values just mean you can also have intervals for your variable here. So your variable can be written out with each value if you have sort of not very many options for what your variable could take on, not very many values for what your data could take on. And then if you have a lot of different values for what your data could be, then you might want to split it up. like we've done here with the 1 to 10, 11 to 20, 21 to 30, and so on. All right, so I'm going to erase this. So if you need to take a screenshot or get this written down, then you might want to pause it. All right, so I'm going to erase it now. Try to anyway. Okay, so frequency distribution is a way that we can summarize the data. It's going to show how often each value or range of values occurs. The main purpose of a frequency distribution is to organize the data. All right, so if I give you just a huge list of numbers, you're not going to be able to really tell a whole lot about it without organizing it. All right, so the whole purpose of a frequency distribution is it gives us a way to organize the data, which is going to allow us to more easily identify the patterns or understand the distribution of the data. Now, they use the word distribution pretty, fast and loose here. So sometimes they'll use the word distribution to refer to a graph or a chart or a table. But most of the time in statistics, when we see the word distribution, that's referring to how the data are spread out. And maybe that's why in some books you'll see them called frequency tables instead of frequency distributions. All right, so maybe a better name for them is a frequency table. All right, so frequency tables are going to organize our data. It's going to make it easier for us to see patterns and understand how the data are spread out. All right, so before we start constructing our first frequency table, we're going to talk about some important vocabulary that you're going to see or that you're going to hear me using during today's video. All right, so the class width. The class width is the difference. We know that difference means what operation? Subtraction. So it's the difference between the lower limits of two consecutive classes in a frequency, let's call this a table. All right, so it is the difference between the lower class limits of two consecutive, that means one right after the other, all right, so it's the difference between the lower limits of two consecutive classes in a frequency table. All right, so this is specifically referring to those frequency tables like we saw a minute ago, like with the ages. And we'll do frequency. So this is specifically referring to when you have a range of values. So like 0 to 10, 11 to 20, 20, oops, not 20, 21, 21 to 30, 31 to 40, and we'll just stop at 41 to 50. All right, so let me give you an example of a class width. All right, so you would take the lower limits of two consecutive classes. All right, so two consecutive classes, the classes is referring to each one of these little ranges. All right, so you might call this one class 1. This one you might call class 2. Whoops, class 3. This 21 to 30. My arrow kind of got wonky. All right, class 4 would be 31 to 40. Class 5, 41 to 50. All right, if we're talking about the lower limits of two consecutive classes, all right, this is the lower limit, this is the upper limit. All right, so the difference between the lower limits of two consecutive classes. All right, so always do bigger minus smaller. All right, so we're going to do 11 minus 0. You know what? I've made a little mistake here. I should have labeled this 1 instead of 0, because otherwise it throws the rest of this off. All right, so I'm going to label that 1 instead of 0. You'll see why I had to do that in just a minute. All right, so class width is kind of like a little formula. We said it's the difference between the lower limits of 2 consecutive classes. So I'm going to do lower limit of class 2 minus lower limit, limit of class 1. Right, so that's going to be 11 minus 1, which is 10. Now you can recalculate this for each combination. You can do the lower limit of class 3 minus the lower limit of class 2. You're going to get the same answer, right? It's 21 minus 11 is 10. Right, so that's why I had to change that one to 1 instead of 0, because if I had left it at 0, it would have, the class width would not have been the same for that first one. So the class width is 10 for our little example here. Class width equals 10. All right, so each frequency table is going to have its own class width. Okay, so this is just an example. All right, let's look at our next vocabulary word. Lower class limit. Well, we've already talked about the lower class limit. It's the smallest number that can belong to a particular class in a frequency table. So with our little table from before, ages, frequency, 1 to 10, 11 to 20, and so on. The lower class limit for our first class would have been 1. The lower class limit for our second class would have been 11. The upper class limit is just the opposite. It's going to be the largest value that can belong to a particular class in a frequency distribution. So again, with our little example, ages, frequency, 1 to 10, 11 to 20, and so on. The upper class limit for the first class would be 10. The upper class limit for the second class would be 20. All right, class boundary. This is one that always messes people up, so I want you to take good notes on this one. All right, so the class boundary. The class boundary is sort of like the midway point between the two classes. All right, so thinking back to our little example with the ages and the frequency, 1 to 10, 11 to 20, 21 to 30, 31 to 40. All right, we'll stop there. The class boundary is basically what is the halfway point between the end of the first class and the beginning of the next class. All right, so what's the halfway point between 10 and 11? It's 10.5. All right, so a lot of times you don't even need to, you don't have to make this complicated. You can just think to yourself, okay, if I was trying to get in between 10 and 11, what's the halfway point? Of course, it's halfway between 10 and 11 is 10 and a half. All right, so here's the formal definition for class boundary. Is the halfway point between the upper limit of one class and the lower limit of the next class. All right, so it's the halfway point. All right, the relative frequency. People very, very frequently get this mixed up with cumulative frequency whenever we take the test. Make sure that when you make your little formula sheet or when you're taking notes on this, make sure that you know the difference between relative frequency and cumulative frequency. Remember, the word frequency means count. So relative frequency is how large was the count relative to everyone else. All right, so relative frequency It's just a formula, frequency over the total. And this is going to give you an idea of like what percentage of my data values, what percentage of my data points fell into that category. All right, so was it a large percentage or was it a small percentage? All right, and again, just reading this and interpreting it intuitively, frequency means count. So this is how large is the count relative to all of the other data points in my data set. All right, very simple formula for frequency, or excuse me, for relative frequency. It's just the frequency divided by the total. The total is add up all of the people that were in your data set. How many people did you survey? All right, now cumulative frequency. Think about whenever someone says like you have a cumulative final exam. Cumulative final exam. If you had a cumulative final exam, that would be like saying it covers everything we've done all semester. Same thing with the frequency here. So this is saying add up all the counts up until this point. All right, so it's the sum of the frequencies. Sum means add. All right, so sum means add. Add up all the frequencies of all of the classes up to and including a particular class. All right, so let me give you a little example. All right, I'm going to do the same thing again, ages, frequency. Okay, so let's just do our very basic, like 1, 2, 3, 4, 5, 6. And then I'm just going to make these up. It's not going to match that one that we did originally. I'm just going to say 5, 1, 3, 6, 8, 1. All right, remember the frequency is you're saying like how many times did we have a 1-year-old in the data set? We had 5 1-year-olds. Sorry, I don't think you could see my pointer there. I had 5 1-year-olds. I had 1 2-year-old. I had 3 3-year-olds. 6 4-year-olds. 8 5-year-olds. 1 6-year-old. All right, so if I asked you to find the cumulative frequency, all you're doing, let me switch to my laser, is adding up the frequencies of all classes up to and including that particular class. All right, so for the first row of your frequency table, it's going to just stay the same. You just copy that frequency right over. Then you start adding. 5 plus 1 is 6. 6 plus 3 is 9. 9 plus 6 is 15. 15 plus 8 is 23. Is that right? Let me make sure. 15 plus 8 is 23. Killing it. All right, plus 1 is 24. All right, so the cumulative frequency, all you're doing is adding up the frequencies of that class plus all the previous classes. This class, the 3-year-olds plus the 2-year-olds plus the 1-year-olds. If you're doing the cumulative frequency of the 5-year-olds, it's going to be the 5-year-olds plus the 4-year-olds plus the 3-year-olds plus the 2-year-olds plus the 1-year-olds. Right now, if you were asked to find the relative frequency, remember that's going to be the frequency over the total. We just found the total, whether we knew it or not, is 24. If you add up all these numbers, they add to 24. All right, so our total was 24. That means we surveyed 24 children in this study. So looking at my frequency column, not my cumulative frequency column, that's going to be 5 over 24. Then for 2-year-olds, 1 over 24. 3-year-olds, 3 over 24. Now they want these fractions in simplest form, so that's going to be 3 over 24 simplifies to 1/8. Then we have 6 over 24. That simplifies to 1/4. 8 over 24 simplifies to 1/3. Sorry, my writing's getting like microscopic. And then our last one is 1 over 24. All right, so the relative frequency is, remember that formula, frequency over the total, whereas the cumulative frequency, you're just adding up all of those frequencies. All right, here's an example. My goodness, I've already got the total written down there. That was my bad. I meant to make that pop up in a minute. It says, consider the following frequency table representing the eye colors of some randomly selected students in my stats class. So here we have some eye colors. This is not, what's the right word? Like, this is not all of the possible eye colors. This is just a sample. So we have people with blue eyes, brown eyes, green eyes, gray eyes, and hazel eyes. In this particular sample, I had 20 people with blue eyes, 47 people with brown eyes, 7 people with green eyes, 2 people with gray eyes, and then 6 people with hazel eyes. You can see I've already added these numbers up. 20 plus 47 plus 7 plus 2 plus 6, they add to 82. All right, so that's the total. All right, and we're asked to find the relative frequency. All right, so the relative frequency for blue eyes, it's going to be the frequency over the total. Frequency over the total. All right, so for blue eyes, that's going to be 20 over 82. Now, again, that can simplify. You're totally welcome to do this in your calculator. These are both divisible by 2. So that simplifies to 10 over 41. For brown eyes, we had 47 people with brown eyes. So we have 47 over 82, and that does not simplify. All right, for green eyes, we have 7 out of 82. That does not simplify. For gray eyes, we have 2 out of 82. Those are both divisible by 2, so that reduces to 1 over 41. And then for hazel eyes, we had 6 people with hazel eyes. Those are both divisible by 2, so that becomes 3 over 41. All right, so relative frequency is super easy to find, but really easy to mix up as we're going through and we're learning about different types of graphs. It could be easy to forget about the difference between relative frequency and cumulative frequency. So I want to make sure that you get that down on your formula sheet so you don't make that mistake. All right, so here we have a data set that I collected. I want to say it was from Home Depot's website. It says, consider the following data set representing the price of refrigerators in dollars. Let's go ahead and count up how many refrigerators we have in our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, so we've got 22 refrigerators in our data set. That's our total. We'll carry that over to the next page. 22. All right. So we are supposed to fill out this frequency table for the price of refrigerators. You can see I've already got the classes spread out for you. I've already got them spaced out in the appropriate way. That's not something that I'm expecting you to do at this level. That might be something that you are expected to do if you went to like Stats 2, but for now I will give you the range or the interval for the data values. All right, so our first class is going to be refrigerators that cost between $1,068 and $1,127. The next class is going to be $1,128 to $1,187, $1,188 to $1,247, and so on. All right, so for our frequency, we know, and we'll go ahead and write over before we forget, or before I forget, that the total number of refrigerators was 22. Alright, so frequency, we're just counting up how many refrigerators fell into that range. You can see I've already got the first ones marked out. So how many refrigerators were in between 1,068 and 1,127. There was this third one, the next row, that third one, and then 4, 5, 6, 7, 8, that eighth one in that bottom row. So all three of those fall within the first class. All right, so 3. Whoa, 4. That was an extra one. My bad. There's 1085 was also in there. All right, so in case that just confused you, let me back up a little bit. The number of refrigerators that were in between 1068 and 1127, if you're going through the first row, there's 1094. There's nothing else in the first row. And then 1085, that's in between those two numbers. 1127 is at the very end, but it is in between. And 1076, that's definitely in that first class. All right, so we have 4 refrigerators that fell into that first class. Right now we're looking at how many refrigerators were in between 1128 and 1187. I always, to do this, I focus on the larger number, so I'm saying like, okay, is this less than 1187? No. Is this less than 1187? No. Is this one less than 1187? No. So you're just going through and asking yourself that for everyone. Here's the first one, 1143. All right, going on down the first row. I don't see anything else in the first row. Go down to the second row. 1374, definitely not. 1151, yes. All right, 1230, nope, too big. 1151, yes. 1249, too big. 1388, 1322, both too big. All right, so count up how many tick marks for the second class. That was 1, 2, 3. All right, next we're looking at refrigerators that were in between 1188 and 1247. So again, we're looking at like how many were less than 1247. No, not less than 1247, not less than 1247, not less than 1247, not less than 1247. Moving on down, yes, 1234 is less than 1247. Neither of those fall into that category. 1374, too big. 1230, that's less than 1247. All right, 1249, nope, a little bit too big. 1388, 1322, both too big. All right, so in the third class, we had 2 refrigerators. All right, next we're looking in between 1248 and 1307. All right, so think less than 1307. Nope, 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 nope. 1307, nope, still too big. 1307, too big. 1307, 1307, both of those are too big. 1374, too large. 1249 works. All right, 1388, 1322, both too big. All right, so just one fell into that category. Right now we're looking at what's left over that's less than 1367. All right, 1364, that one works. 1335, that one works. 1377, a little bit too big. 1398, again, a little bit too big. Too big. 1374, yep, still too big. We've got to be less than 1367. All right, and then 1322, that one works. All right, so in that category, we had 1, 2, 3. And then what's left over? 1, 2, 3, 4, 5, 6, 7. Did I miss one? 1, 2, 3, 4, 5, 6. Yes, I did. 7, 8. Y'all don't trust me. I'll be counting wrong. All right, so we've got our frequencies added up. One way that you can check yourself on your frequencies is you can add all of these numbers up and make sure they match your total. All right, so let's do that really quickly. Just grabbing my calculator. If you want to grab yours and start adding those together, 4 plus 3 plus 2 plus 1 plus 3 plus 8. That adds 21. Did we miss one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12, 13, 14, 15, 16, 17, We must have counted wrong on the last page. Alright, we'll fix it. Boom. Okay, there's actually only 21. Y'all, I'll be struggling. Alright, let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, 21 is right. I was wrong originally. 21 is the correct number. Alright, now let's do our class boundaries. So on class boundaries, we're going to go either direction. So a little bit lower. So what would be the lower class boundary? What would be the upper class boundary? So let's first figure out what's the halfway point. All right, so what's the halfway point between 1127 and 1128? Of course, that's going to be 1127.5. All right, so we're going to do the same thing on the lower end. So we're going to subtract 0.5. So 1068 minus 0.5, that's going to be 1067.5 to 1127.5. All right, so what did I do there? I just said, okay, what is the halfway point between these two? That would be 1127.5. That means I went up, or I added 0.5 to the upper class limit. To get my lower class boundary, I need to do the opposite. I need to subtract 0.5 from the lower class limit. All right, so that's where that 1067.5 comes from. So you figure out, okay, what did I have to add to get to that halfway point? Now I'm going to do the opposite to the lower class limit. All right, so don't overcomplicate this. I promise. This is just one of those things. We're only going to do this one time. This is not something that we'll be doing over and over and over. And this is typically not something that I would put on the test. All right, so calculating the frequency, calculating the midpoint, relative frequency, cumulative frequency, those are easy. The class boundaries are challenging, and I don't want you to think that that's something that I'm going to be asking you to do all the time. This is sort of a one-off type of deal. All right, so let's keep on chugging. All right, now we're going in between the next two. 1187 to 1188, that's going to be 1187.5. All right, 1187.5. All right, that's going to be your upper class limit. To get to the lower, or excuse me, that's going to be the upper class boundary. To get the lower class boundary, remember what we did? The exact opposite. We go to our lower limit. We go to our lower limit, and we subtract 0.5. That's going to get us to that 1127.5. You're going to notice that this happens every time. The upper limit, the upper class boundary from the previous class is going to transfer down, and it's going to become the lower class boundary for the next class. All right, so you're about to see that again. So this one is going to transfer down here. Then we just have to add 0.5 to get that upper class boundary. All right, then again, transfer that one down, 1247.5. Add 0.5, 1307.5. And I've got the dash here. This is not saying like that this number to this number. This is just, I really should have put like a long straight line in between those. All right, so again, this is transferring over 1307.5. Add that 0.5, that's 1367.5. Drop that down, 1367.5. Add the 0.5, 1427.5. All right, so those are my class boundaries. Okay. Just erasing those. They're about to pop back up. I have them typed in there. Okay, there those are. All right, midpoint. Midpoint. We're talking about the original class here. I'm going to draw a line down here so we understand that these are just two separate values. The lower class boundary and the upper class boundary. All right, the midpoint, we're looking at the original classes and we're saying, okay, what's the halfway point between the lower class limit and the upper class limit? All right, so LCL equals lower class limit. UCL equals upper class limit. All right, so to get the halfway point, you are just going to add those two together, or excuse me, subtract those, 1127 minus 1068, and then divide that by 2. All right, so 1127 minus 1068 is 59 over 2. 59 over 2 is 29.5. All right, so to get to the midpoint, we need to add 29.5. All right, so we're adding 29.5 to our lower class limit. 1068 plus 29.5. The halfway point would be 1097.5. So that would be halfway in between 1068 and 1127. So again, what I did there is I did upper class limit minus lower class limit over 2. That's telling me, okay, how far do I need to go to get to the halfway point? Okay, so I needed to do an additional 29.5. So I'm going to add 29.5 each time to the lower class limit to get my midpoint. Each class has its own midpoint. All right, so each time I'm just taking that lower class limit, adding 29.5. Lower class limit, add 29.5. All right, so you might have to pause the video in here to make sure that you're able to keep up and get everything written down. Again, just adding 29.5 each time. All right, then now we're getting into the good stuff. So this is the type of stuff that we're going to be doing on the test. All right, so relative frequency, cumulative frequency, and then of course also frequency. All right, so relative frequency, remember that's that little formula, frequency over the total, which we found out was 21 instead of 22 like I originally said. All right, so relative frequency is going to be 4 over 21. All right, that doesn't simplify, so we'll leave it at that. For the next class, it's 3 over 21. That one does simplify. All right, so we're looking at 3 over 21, which does simplify. That becomes 1 over 7. For the next class, 2 over 21. That doesn't simplify. Then 1 over 21. That doesn't simplify. 3 over 21 again, which we just said simplified to 1 over 7. And then 8 over 21, which does not simplify. All right, and then cumulative frequency. Remember, this is where you're adding up those frequencies. So for the first one, it's just going to copy over. Then you start adding. So 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 1 is 10. 10 plus 3 is 13. 13 plus 8 is 21. All right, that is everything for this video. I know that was a lot of information. I appreciate you watching this whole thing. And if you have any questions, I hope you will let me know. And I'll see you next time.